Alright, in this video we're going to go over the design and build of this mechanical clock. This clock is actually a highly modified version of Brian Law's Clock 53, which is pendulum powered. It's got the black pendulum power source back there that runs off of two AA batteries. The pendulum will increment the gear on top once a second, and that will actually make all of the rest of the gears spin as time goes by. Alright, for this clock I wanted it to be wall mountable because the original was not, and I wanted the legs to touch the wall. I wanted it to have enough room for the pendulum to swing underneath, and I wanted the legs to come up around here to hold the face and give it kind of like a spider or a Dr. Octopus kind of feel to it. So I designed the wooden part in back, the legs, and the face of it I redid so that I could cut it out on my laser. Alright, I wanted to show you where I got the files to 3D print and cut out. This is Brian Law's website. I went to Clock 53 and purchased the plans for this clock. The plans include the DXF and STL files so that I could 3D print or cut out the files on the router. Even though it's under $30, it is highly worth it. If you have a 3D printer or a CNC router, I really recommend at least trying one of these clocks. It's well worth it, and when you do get the instructions, they are going to be super detailed and easy to follow, and you will be able to either modify or change the design just like I did. He gives all of the dimensional drawings, measurements, and really makes it easy to understand how the clock is put together. There's even YouTube videos on how to assemble these clocks. So if you haven't already, I highly recommend just giving it a try. It is worth the money. So once I have the files to 3D print, I went ahead and drew up the new parts that I wanted for my clock in Fusion 360. These right here are really the only parts that I drew. They are oriented right now in a way that when I generate the G-code for it, it will have the grain of the wood go up and down, which on these leg parts really is necessary for the strength. Since the grain is going to be a little bit weak in some areas, I wanted to make sure they were oriented correctly. So for each of these, when I do go to the manufacturer section to generate the G-code, I use a different setup for each one so that I can cut out each part individually and tell the machine that I want to start in a specific part or location, and this works out quite well for me. So one thing to note about Fusion 360 is that it will not do a tool change mid-part. This is the personal version, and it does not allow tool changes in one part. It also does not allow you to go super fast for the rapids, which for me is not a big deal. I'm using the personal version, but if you wanted to upgrade and get those features, it is going to be very useful for larger parts. Alright, one thing I forgot to mention is that I did draw up the face of the clock in Fusion 360, and we can look at it here. I used Fusion 360 because I could basically put text on there and then rotate it to a specific position. When I was done with this, I exported it to a DXF file and I imported it into the Inkscape. And in Inkscape, I changed the colors so that I can have a raster or outline cut, as well as the red for the cut that goes all the way through the wood. So in this particular design, I did not use the outline feature. I let the router just do the raster on the black part and then cut the outline that's in red. So that worked great. Alright, I've mounted my material here. This is red oak, about 1/4 inch thick from the local hardware store. I've screwed it into my sacrificial back plate here. I've got an 1/8 inch, probably a 3 flute end mill on there. So I'm going to go ahead and start up LinuxCNC. Alright, I have the next part loaded. It's going to be one of the legs of the clock. I went ahead and touched off my tool positions. This 3D printed part is where it's going to give me an idea of where it's going to go on the board. So we're at the 0 position now. I've raised it up a little bit off of the workpiece just so I can move it around, but it is all zeroed out. So I'm going to go ahead and press the play button. Okay, that came out really well. So just need to clean up the edges a little bit and that'll be perfect. I'm going to set this up to do another leg and get the new touch off point. So here we're back up here X-axis, touch off. Okay. Y-axis, touch off. Okay. So you can see that moved the new part up here. I'm going to hit Control K to remove the previous toolpath of where it was and hit the play button. Alright, so that one didn't quite go all the way through, but it's not too difficult to free it up. There we go. Perfect. Alright, I just wanted to show you the status of where we're at. This right here is going to be right there. The clear plexiglass face of the clock is going to go around here and be held by these, and the rest of the gears are going to be right in here. This one is going to be like that. So that's what it's going to look like. Super excited. This is starting to turn out quite well. So I like a nice clean curved edge on the hardwood that after I go ahead and cut it. And typically I've always used a router bit like this, but in this case the bearing is kind of too high for the material I'm working with, and you almost need a template on top of the material to let the bearing ride on. So for this, I think I'm gonna use a different bit. This is for a Dremel that I've chucked up in the mill, and I'm gonna pull the spindle down and lock it in place, and then use my hands to hold the material down while the mill is cutting the curve on the edge. So I'm gonna take these pieces off of my vise so that it's got a nice flat surface for me to hold the material down on. When the bit is in a router table like this one here, the neat thing about it is if your material comes up at all, it doesn't cut. So in this configuration where the bit is on top and going down, I really need to make sure that I hold the material down, because if it comes up at all, the bit is actually going to cut more than what I want it to. So I think this will work out good though.
All right, I have stained a scrap piece of wood here with two different stains. On the left is a light oak wood stain, and on the right is a dark walnut. I think the light oak is gonna work best for my house and decor and the overall look of the clock, so I think I'm gonna use that one. Alright, one of the ways that I found to get the 3D printed parts to fit into the holes in the wood real good is to use a reamer. Once you have the part cut out, ream the hole to where it's just big enough to have a nice snug fit for the 3D printed part. That'll hang on to it real good. We'll go ahead and glue those in place, and when we do, we want to make sure that the gears spin on the shafts, but we want to make sure that the gear itself is not tilting it one way or the other. So what I'm going to do is use some epoxy. That will give me a couple minutes to get everything oriented correctly and make sure that the gears aren't tilting before the glue dries. Alright, originally I wanted to do an acrylic face to the clock, and I thought it was going to work out okay, but it was going to be difficult to put the numbers on the front, and I thought having a laser cut or engraved numbers on it would be much easier to read and give it an overall better appearance. So that's why I went with the laser cut wood instead of the acrylic. Alright, I've got the clock on the wall and it is almost working. The pendulum doesn't have quite enough energy in it to tick every time, so it's gonna tick and then swing once or twice and then tick again. So it's close, but I think it needs more voltage. Alright, it's been clicking away for about 15 minutes or so. It's running right now at 2.7 volts. I've had it up as high as about 3.3, and it seems to work pretty consistently between these two voltages. So right now it's running off of a single AA, but I think what I'm going to do is run it off of a set of two AA's. That will give me about 3 volts depending on their charge, and that should be all that it needs to run consistently. Alright, that's about it for this video. Thank you for watching. Please click the like button or subscribe if you haven't done so already. I plan on doing some more builds and interesting videos in the future, so please check back later. Thank you very much.